Hello and welcome back. Integration for year 13. No enrichment, straightforward integration. How hard is this question? I haven't actually looked at it in detail because I only wrote it a few hours ago, and it's going to go in one of my further maths papers. I will probably say that's probably a 3-star standard stuff for exam, maybe a little bit on the hard side to get you going, but it's not that difficult. And I think probably I will actually show that this particular integral is in fact, I hope it was pi over 2. I can't quite remember when I'd done the question last night what answer I got. This is question mark, so I can't quite remember the answer, but I will put it as a show. Okay, how do we do a question like this? It's the first thing to ask. First of all, I hope you can see it's an arctange there, inverse hyperbolic tangent. Quite clearly is some kind of integration by parts. I could think of a substitution, perhaps replacing the argument of the arctange that cos with something else, call it u perhaps. So I would try the substitution first of all, just to see how it works. I didn't try it when I was doing the solution because quite clearly I can see what I need to do in there. But let's see if that works, for example. So let's say, okay, let's use the substitution u is equal to the cos of x. Just see what happens. Okay, so we'll differentiate it. Du by dx is going to be equal to a negative sine of x. And of course, my dx will be equal to du over minus sine x. And the limits, if that's a cos, they will go at the 0 will map into a 1, and the pi over 2 will map into a 0. So this is just trying at the moment, just to see how this will change if I do it this way. I didn't do it that way, by the way, as I just mentioned. So this is going to be a 1 to 0. The cos of x, I called it u. And then I'm going to have the r tanh of u. And then, of course, I'm going to have my dx, which is a minus du over sine x. So the problem now is, what do I do with this sign here? Everything has gone into use. The minus will reverse my limits again, but I'm stuck with this ugly sign in there. And I can think perhaps of saying, well, maybe something like this is 1 minus cos squared of x. Let's ignore the plus or minus for the time being, just to be honest, just till we see what happens. And then I can possibly have for this bit here a 1 minus u squared in the square root. I definitely do not even want to continue with this. This is part of the reason I'm showing you this is because as a student you should be trying things, and perhaps because I wrote the question, I know how it works, because I didn't even consider doing something like that. But as a student, if I was to be faced that somebody else wrote this question, okay, the first thing probably I would have done is something like this, and then I would have hit a brick wall as you just saw it live now, and I would have just said, okay, I'm gonna have to do something else here. Okay, so let's wrap off this workings. We had an unsuccessful attempt, no problem, didn't take that long. And let's think what's the alternatives here. Okay, I'm going to go for some kind of integration by parts. So the thing is, what do I differentiate and what do I integrate? I have this arctange. Well, I know what arctange differentiates to, and if you don't, it's in the formula booklet. And definitely, I don't fancy, if I would do integration by parts, to actually integrate an arctange. So I'm going to proceed and actually mention, this is straight off your formula booklet, that the differential with respect to x of the r tanh of x is 1 over 1 minus x squared, and the differentiation. So we're going to use this result. I'm going to leave it here and I'm going to wrap it off in a minute. So I'm going to do my parts up here. So I'm going to say, okay, I'm going to differentiate the r tanh of the cos of x, and I'm going to integrate the cos, which of course very easy to integrate. It comes of course from the differentiation of a sine. And what does that differentiate? Well, that will differentiate to 1 over, looking at this result here, 1 minus the square of the argument. So it's going to be 1 minus cos squared of x, which is rather nice because it's an identity, times the differential of that. I don't have room here, so I'm going to rub off the 1 here and put it on the top. So it's going to be minus the sine of x from differentiating, of course, the cos of x. Let's make some room. Let's rub that off. And let's see what happens now in the next line. I'm going to rub off the pi over 2 because after all, it might not even be pi over 2. And do my part, so that's the product of these two quantities. So that is equal to the sine of x times the r tanh of the cos of x between the limits of 0 and pi over 2. And for that, I need to subtract the product of this diagonal in an integral. So 0 to pi over 2. And I have a minus. And of course, I have another minus from the minus sign next in there. So I'm not going to waste the line. I'm going to put that into a plus. I took care of this minus now. And I've got sine squared on the top, sine times sine. And on the denominator, I have 1 minus cos squared, which on the next line, it will simplify massively. This is actually quite pathetic. And I'm going to actually do it here. 1 minus cos squared, of course, is the sine squared. Sine squared over sine squared. This is, in fact, 1. Okay, all of this. So that's very easy to integrate. The integral of 1 between 0 and pi over 2, it will produce a pi over 2. So if I was writing my answer that I just quoted up there, this better be 0. So let's have a look what we're getting for this particular one. First of all, I can use my calculator, but I don't have it. And secondly, let's do a few more things. The r tanh, it has a logarithmic form. I'm going to write it here. The r tanh of x is a half log, I think it's got 1 plus x on the top and 1 minus x at the bottom. I think that's correct. I hope it's not the other way around, otherwise it'll be, it will not make a difference actually in this particular question, just looking at it now, but I think that's the right way. It's in the formula booklet, or you can easily prove it. Okay, so in this particular case, the half from the r tanh, I'm going to put at the front. That's a half log, and the r tanh is of cos of x, going to be the log of 1 plus the cos of x. I'm going to move my arm out of the way to actually see the formula as well as what I'm writing afterwards. So this is now the r tanh of x is that, so the r tanh of cos of x will be, of course, exactly the same thing, but with a cos. So that's this bit here, times the sine of x. I haven't evaluated anything yet, so I can actually see what's going on. Okay, that pi over 2 comes obviously from that simple integration in there. Let's see what happens. When I put pi over 2, first of all, on the lower limit, when x is equal to 0, this is dead because of the sign. The sign of 0 is 0, so there's nothing on the bottom limit. So what happens when I put pi over 2? When I put pi over 2, the sine of pi over 2 will be, of course, times 1. That's 1 from there. So the question is, what is that? The cos of pi over 2 is 0. So that's going to be times the log. This is 0, this is 0, 1 over 1, which is the log of 1. And of course, the log of 1 is 0. And this gives 0 on the upper limit, 0 on the lower limit. And of course, the only thing that survives from this integral is just the pi over 2. Okay? I hope you followed. Yeah, I don't think it was that hard. Is it 3-star or is it 3.5? Maybe somewhere in the middle, depending on my mood when I actually put into my exam. I don't know, in my paper rather. I will decide there. I hope you enjoyed it. I hope you followed it. And who's laughing now?